Hello everyone, welcome back to another video. Thank you so much for joining me today, and I hope you're doing well, and I hope you're staying safe and sane in this ever-changing world. Once again, it's great to have you again coming back for another lesson. In today's lesson, we're going to be looking at constant variables and data types. All right, so I hope you are being able to do your homework or do some reading or played around with the earlier provided code. So for this lesson today, I'm going to put the link in the description for the items or the slides and everything we need. So just go ahead and click the link and download it. So today's lesson, we're going to be looking at constant variables and data types. So these are things that we use in programming, or more or less the entire time while we are creating applications and so on and so forth. And in this lesson, we're going to be learning some new vocabulary. We're going to be looking at bool, constant, int, comment, doubles, functions, immutable, mutable, properties, type inference, type safety, variable, and var. So this is a mix of data types and also properties, things that are associated with properties and of that nature. And we're going to be able to hit these goals by the end of this lesson. This is going to be a long one, so I'm going to try and move as fast as I can, as quickly as I can. All right, so what are constants and variables, right? So let's say you've heard of the word constant before, right? So when you hear of the word constant, what comes to mind? You know that it's something that usually doesn't change. So a constant is something that we create in a program to refer to something else that would never change over the life of the program. So we try to represent things in the program. We store them. For instance, in this case, let's say we have a name and we want to call that name John. So we store that in this name, and this name is going to be the constant. And what makes it the constant is the keywords, right? So the keyword let would make it a constant. That is to tell us that this constant will not change, and then we can assign it whatever we want. To make this easier, we can open our previous playground, lesson 1, and I'm just gonna show some code. All right, so what's the difference between, don't worry about this one right now, let me put this one right here. Okay, so in programming, we store things and we use them several times as much as possible. So let's say we want to create a name of a person, and we use the keyword let name equal to John, right? So this name is a constant, and the reason why it's a constant is we cannot change it over time. Now this let keyword, we call this a keyword, and this keyword signifies that this name here is not going to change, and this equal to sign is not equal to sign. So this is an assignment operator. So that means that whatever is on the right hand side, we are trying to store it in the left hand side. So this this word on the right hand side is a type, and this type is a string. So we're trying to assign it to this name, which is a constant. So what we're saying technically is we are telling the compiler to allocate some memory that we want to store some data types, right? We want to tell it that I want you to save maybe 10 bytes, 2 bytes, or whatever size the type might hold in that memory. So we want to tell it, give me this space and I want to store John inside that space, and John is a string. So whenever we call, we call it by referring to that constant like this, and you can see it prints it out, John. Usually for a string there's a new line attached, and we'll get to that in a while. So what makes it a constant? This is what makes it a constant. Let's say we have var and we want to say age, and we say age is 18 like this, right? Or let's even make it let's even use a string so that it'll be easier to understand. Let's say last name, right? And then we say last name is, let's say, Cuban. Okay, so if we print the last name, right, last name, we're gonna have Cuban, right? So let's now say we want to, maybe over time, we want to change the name and give it some other name. So let's say the name is let's say name, we want to change it to Frank, something like this, right? Now we'll get an error, and it says cannot assign value, name is a let constant, meaning that we cannot assign a new thing to this constant that we've declared in the beginning, right? So this constant is not going to change in the entire course of the program. That's why we're using the let keyword. So if we do like let's say we say last name is equal to Frank, or we assign Frank to the last name, now if we print it, it's no longer going to be Cuban, right? It's going to be the new thing we changed it to. So the difference between a variable and a constant is, a variable is something that we can always change. Like, think about a variable, think about a knob, something that you vary, right? It varies, all right, from the word varies. So variable means that it will change over time. It can be something in the beginning, and it can change over the course of the program. So that's the difference between a constant and a variable, right? So we are telling the program allocate this space in memory so that I'll store this data type, and then we store whatever we want to store, be it a number, a string, or whatever we want to create. But the difference between a constant and a variable is constant will not change. It will be that same way over the course of the program. All right, so this is what we just did right now. We just tried to change a constant, and we know that you cannot change a constant, right? Okay, and then we can also try this, right? We can do numbers as well. So let's say we have, let me see, var age is let's say 27, right? And then we say age again is age plus 1. So what's it gonna be when we're trying to print age, right? So what are we doing here? We are taking the previous value of age. So we say age is 27. So when we come back here, so you always want to read it from the right hand side to the left hand side, because of we are trying to assign to that variable or constant, right? That's what this equal to sign means. So this age is this value that we assign to it in the beginning, 27. So we get that value by calling it, right? And 27, that's going to appear here, plus 1, right? So we assign that again back to the age variable, and then we print it. So what's it going to be? 28, right? and then you can see that it did the sum here. So that's how variable is. But if we try and make this a constant, right, now it tells us we cannot assign to a constant. Okay, so that's the difference between a variable and a constant. Okay, all right. So basically in the program, we're going to have so many variables, we're going to have so many constants, and the entire program is just once you start your app, it is just going to be referencing or calling all those things that you stored, and we are trying to manipulate it and use it inside the entire program, right? Showing you images, showing you words, showing you text, and whenever you change something, it updates. So we are trying to store it using a constant and a variable, and then some things wouldn't change in the entire course of the program. Let's say you are assigned a fixed username in your app that you can never change, right? Like in Instagram, so that would be a constant, right? Let's say your bio, right? If you're feeling excited today, you can change your bio. If you're feeling a little bit motivated, you can also update it, right? Or if you travel to France, you can change your bio. So if you can change this, that means it's stored in a variable. So that's just a lot of things that goes on in the entire program. Okay, so remember the keyword for variable is var, and the keyword for constant is let. Okay. All right, and we did something like this, right? So if you have a default score of 100, a default constant, and you have a variable of player 1, and you assign the default score to player 1 and assign the default score to a variable of player 2, right? So player 1 and player 2 will have both what now? 100, right? And when you print player 1 score and print player 2 score, right, you're gonna have what? You're gonna have what? 100, right? Because you assign those two things to it. But now when you change player 1 score, and player 1 is a variable, remember that, you change it to 200, what are you going to have when you print or call player 1 score, right? You're gonna have 200 because you just changed it right here. So that's how a variable works. So let's say you're starting on a journey, right? You're going somewhere, and you want to represent these values. So you have the starting location, you have the destination right here, you have the current location where you're staying, you have the distance traveled, and you have the remaining distance. So how would you represent these values? Using either a variable or a constant. Okay, so let's look at each one of them. So a starting location is going to be the starting point, right? And once you start, right, it's not going to change. It's always going to be a starting point. There's always going to be only one starting point when you started. So that starting point will not change. So this will be a constant, right? So maybe we can say something like this. Say travel. And then we can say let starting point, or we can say 200, or we can say 200. Any way we want to represent it, right? But the point is, starting point is going to be a constant. Okay, and then what about, which other one do you think it's going to be a constant, right? Is it distance traveled, current location, remaining distance, or destination? So you're starting somewhere and you're going somewhere, you know where you're going, right? If where you're going changes, then that's not your destination. You're gonna get lost, right? So your destination has to be fixed. If you're going to Catella Avenue, right? It has to be fixed. It shouldn't change. So destination is going to be a constant, right? And this one is like that. So the destination is not going to change in the entire course of the program. We don't want it to change, because if it changes, then we'll get lost, right? It's going to be like driving pointlessly. So what about distance traveled? Right? How do we get the distance traveled? Well, if we take the current location and we subtract it from the starting location, right, then we get the distance traveled, right? So let's say starting location, let's make it a number instead, right? So let's say this is 200 kilometers or whatever, right? And then we say var, because it's going to be a variable, right? We're talking about distance traveled. So distance traveled is what? Current location, right? This current location minus the starting point. So current location minus starting point, right? So we don't have current location yet, so let's declare current location, and we can store it as a variable, right? Because the current location will always change while you're driving and while you're moving, right? So current location, let's say right now you are at 50 kilometers or 50 miles, right? So let's say we want to do the math the right way, so we don't have negative. So we just say starting point minus the current location, right? So now if we want to see what our distance traveled is, right, we are currently at 50 and the starting point was 200, right? So the difference, right, so that will work. So that will give us 150. So the point is, how are we storing it? We have to store some as a constant, and then we have to store some as a variable, because those ones will change over time. Because if we move plus 10, right, then the distance traveled will change. So you see, because we've declared it as a variable, it will change whenever this gets updated, right? And this can also get updated. So right now it's 150, but once we try and print it again, it's going to be 140. So what happens to the remaining distance, right? So remaining distance will always change as well, right? Because that one is a variable. So remaining distance could be, let's say, current location minus starting point. However I want to do that math, right? And then we can print it out, right? So you can say we have minus 140 left, right? So if we keep adding 10 kilometers, it will keep reducing, right? So it's 130. Let's say we traveled 30 more kilometers or 30 more miles, right? The remaining will keep reducing. And you can see, if we add 100, right, now it's 0. So we've gotten there. So that's how we create this program. You can see that some things we have to keep them the same, and some things we have to change it over time. So this is how we store so many things in an app or in a program. So you need to know and decide, whenever you're creating an app, which one is going to be my variable once this app starts, and which one is going to be my constant. So that's how constant and variable work. Okay, so you have to know which one you're going to represent as a constant and a variable. Now there are rules for declaring constant and variable. There are rules in Swift for naming them. So we have to follow the convention. Convention is how everything is done in the industry, and the rules is how everything has been set, right? So there's a slight difference. Convention means that is how everyone else is doing it, right? And the rules is you must do it this way. Okay, so always try to follow the convention. Always try to follow the convention so that once you're writing the code for other programmers to see, it's going to be easier for them, and everyone can understand you quickly. You're not going to need an explanation. So if you're creating a constant or a variable, you cannot use mathematical symbols. All right, you cannot use any known mathematical symbols like summation or sigma or things like that. Those are already taken, right? You can use pi, right? Mathematical symbols is like plus. So I take that back. So you can't do something like this, right? You can't do something like that. You can't use divide because those are already taken, right? But you can create yours, but that's another level, right? You can create your own operators and declare how they work. But just for naming constants and variables, this is how we want to do it. We don't want to have spaces, right? As you can see how I named the starting point, I made sure that they are joined together, right? No space. So if you have a space like this, then it cannot process it. So it has to be together like this, right? Okay. And you can't begin with a number, right? You can have like 2 like this. Right? It has to start with a word. Okay. And some words are also valid, so you can use emojis. So emojis, you would say, well, how does this work? Is this a picture? Well, emoji is an ASCII representation. It has a code, right? It has a letter, alphanumeric letter, and that makes it able to be a variable or constant to be used, right? As well as words with special characters like this, mañana, right? And then this one, I will not try to say it. What's this? Anzal da Bucha. Okay, so you can create variables and constant using these names, but you have to remember the rules and the convention, right? So no mathematical symbols, you can't leave spaces, and you can't begin with a number. Okay, another thing to note is when you're naming your constant and variables, you have to be very descriptive and clear, right? So you can say something like for instance, restaurant nearby or restaurants near current city, right? Is better than using nearby. And you can use first name like this, right? So you're trying to use a name that you can remember and would make sense to other programmers when they're reading your code, right? So maybe you made this one X and made this one Y, right? You can come back and say, what is X? What is Y, right? Might not make sense later on because you're going to go back to your code in time. You're always going to refer back. Let's say you wrote it on Friday and you were typing away and you want to go hang out with your friends and you come back on Monday and then you're like, what did I write? What is this? So the more descriptive your variables are and your constants are, the easier and better it is to read, right? We talked about why Swift is the one of the best languages. Is because of the syntax is easy, it's very, very expressive. So when you're creating your program, you want to use good naming convention, right? And then you can use a very, very descriptive name. It's better for the name to be long because once you start using the Swift APIs, the UI kit, you're going to see really long variables and really long constants, and that makes it very, very easy to read and remember. Okay, and then the other thing is, for some words that are two, like in this current location, you can see that I would have written it this way, current location, right? And it could be a little bit like strainy to read, right? I don't know if this size of this I don't know the size of this might have been very, very small, and I apologize if it has been small the whole time, but good thing I caught it halfway. Okay, so I hope this is better than what I was showing earlier. Okay, apologize for that. But yeah, if you name it this way, current location, you can see that it's a little bit like hard on the eyes to read, right? You can say current location, it might be hard to figure it out, but once you capitalize the second word, the first letter of the second word, then it's very, very easy to read, right? Like you can have, in this case, restaurants near current city. So it's better to use this way, and this is called camel casing, right? Writing things like this is called camel casing, trying to imitate the camel's hump, right? Okay, so be clear and descriptive in your naming, and use camel case when you have multiple words, right? Okay, and then comments. You can leave comments, like you can see I lived here. This is a single line comment when you use two strokes like this. Single line comment. Now, comment is something we leave as a note for ourselves or for other programmers. Over time, maybe when you come back to your program, you want to inform yourself about something you wrote, or other programmers, you want to leave a note. So you can use comment like this. So using two strokes or two slashes. Maybe you want to leave a longer comment, right? You can use a slash like this, and then double asterisk, and you can write a note. This is the first lesson on variables, constants, and the types. Okay, so let's say you want to leave a long note. Maybe you want to document your API or your code. You can use a multi-line comment like this to do that. Okay, now you must remember that when you start coding, you don't want to be leaving comments everywhere. It's a kind of I would say it doesn't work in every case for all programmers. Some programmers prefer less comments, and some programmers prefer more comments. You want to make sure that your variables and namings are descriptive enough that you don't need to comment everything, right? So you don't want to comment too much, right? Okay, you want to let your program speak for itself. Okay, all right, so the next thing we're going to look at is types. Now we can store strings like this, words. We can store numbers, right? And so on and so forth. What if we want to create a special type that is not a word or a string? Let's say we want to represent a person, right? So we can say a person like this is going to look like this, and they're going to have a first name, and the first name is going to be a string because it's going to be a word. And then the person can have a last name, right? See how I'm typing that? I'm changing it to camel casing so that it can be legible. So these struct represent a data type like this, the same thing as this one's. So let's say we can use this struct as a variable or a constant. So we can say first person, or we can say Adam, right? And then Adam is person like this, right? And then you can say Adam first human, right? So now we are not, you can see we are assigning a person to Adam variable. That's what we're doing. And then we're going to go through, you know, how to do this, and now we're going to use it over and over again. So this is just what we call creating an instance, right? So we are creating an instance of this type, person, right? There can be number type, words type, and there can be person type, right? We can have so many number types. We can have 1, 2, 3, 4, 5, 200, 500. We can have so many type of words. We can have so many type of person. This, in this case, this one is Adam first human, right? So this Adam is an instance of this type, an example. Think of an instance as an example, right? Let's say Sarah is another person, and maybe we want to call her Sarah Johnson like this, right? So these are two people, Sarah and Johnson. So what happens if we print Adam and Sarah, right? Let's see what happens. Okay, you can see it printed out a person type. And then a person can have not only properties, right? A type can have not only properties, because these are the properties, distinguishing properties that they have. Maybe we want to store age, right? You can say let age and maybe we start with 0, right? Maybe you want to store height. Right? So maybe we want to store height like that. So whatever we want to store that would describe this person, these are the properties, right? So we can have an employee, we can have a student, we can have a house, we can have a phone, we can have any type, right? We can have any type. So type is what we are trying to create or represent. And then we can have an instance of that type, like we have here, Adam and Sarah, right? By initializing it. This is what we call initializing. So we are creating an instance of this type. Okay, so this is a complex data type. This is not a simple one, because not only can we store the properties or attributes, right? These are all properties of attributes of this person, but we can also store function, right? So what is a function? A function is what that type can do, right? An action that the type performs. So maybe a person can say something, a person can maybe eat, or let's say eat meal, right? anything you want this person to do, any action you want your type to perform, right? So this is what we call a function. So let's say in this function, when we say hello, it is going to say something. It's going to print something out to the console. You say hello there, my name is okay. So now whenever we say call, meaning that whenever we invoke or try and tell this person to say hello, to do its function, right, to perform the action, then it's going to do what's inside it, whatever we created or whatever we instructed inside it, right? So how do we do that? How do we call the function of a type? So we can call the function of a type with what we call the dot notation, right? You can just put dot like this, and then we call the function that we want to call. So if we say Adam does say hello, so Adam will say, I said hello. That's not English, right? That's something else. So Adam will say, hello there, my name is first name. And what is first name? First name is what we assigned here, right? So let's see that. So Adam say, hello there, my name is Adam, right? And then we can say Sarah dot say hello, right? So now go ahead and implement something for the eat meal, right? And then pay attention to how you're creating the function. So if you're creating the function, you have to also maintain the convention. You always start with lowercase, and you can use camel case for lots of words, right? So let's say for the eat meal, this person is gonna say yum 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 yum, like that, right? Eating. So when we try and call the function for the instance of Adam, right? Adam the eat meal, what's gonna happen? Right now we have yum 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 yum, right? So Adam is eating. So in essence, we can have data types that we assign to a variable or constant, or we can create our own type, right, and have properties inside the type, distinguishing properties, and also functions or things we want that type to perform or do, right? So that is how we can have a type which is different from what we started with. Okay, so we've done all this one, right? So what are the most common types in Swift? We have an integer, and the symbol is int, and it represents a whole number. So integer is a whole number. Then we have double, right, and the symbol is double, and it represents number requiring decimal point, like that. Then we have a boolean. What's a boolean? A boolean is symbolized by a bool. This is how I would symbolize it, like this, bool, and represent true or false value. So something can either be true or false. That is, it can either be yes or no. So what does it mean? So if we say let is it night right now? It's nighttime right now for me, right? And then if I say it's morning, and I assign it as night, and I try to print what is morning right now. So what is going to be morning? Because I'm assigning what I have is night, right? So I assign this boolean of true to is night, and I assigned it to is morning. So what would I have right now? Right, it's true. And if I change morning, is morning is false because it's night right now, right? So morning is supposed to be what? False, right? So a boolean is something that can either be true or false. This night can either be true or false, right? That's why it's a boolean. There's only two types of value: true or false, yes or no. Okay. And then a string, we've used a string several times, right? A string is a word in quotation, like we have the names and we have all this right here, are strings, right? So there are so many other types of data types. I would encourage you to check out other programming languages data type and see if we have more than this, like what's really going on. Explore other data types, right? So the thing is, these data types are not enough to represent the data that we work with. So for instance, in the earlier days when we have more simpler computers, they only worked with numbers and words. So maybe they wanted to do some calculations or arithmetic, right? They wanted to find balance or whatever. Very simple, just calculate, numbers and letters and words. So as the programs and computer evolved and machine became bigger, now they wanted to store things like maybe fiscal calendar or sales or whatever, or let's say they want to store something big. Maybe they want to store Word documents, or they want to store legal documents, whatever thing they want to store that is not just words. Or maybe they want to represent something that is in the real life in the computer. So you can't say a person is 1 or 2 or string. You want to give it more descriptions. You want to put more properties inside to describe what a person is from the physical representation in a computer, right? So a person can be more than this. You can have hair color, eye color, shoe size, waist. It can be 10 million properties, right? But you don't want it to be exactly a human, right? You're just saying, in this program, this is what a human is. This is how I'm going to represent a human for now, right? So that's what this type means. It means that it's your own representation of what is in the real world in the program. And this is what we call object-oriented programming, right? So we are trying to represent things that we are seeing in the real world and give it a short representation so that we can manipulate it. So that if we take this person that came yesterday and we add $10,000 to his savings account, what is going to be his new balance of his entire bank account, right? Those words, those objects, right, we represent them in structs and classes, right? Struct is easy to pass around because it's just simple data, but there's something called classes as well. We can have a class like this, right? We can put it like this in a class, but it's going to want us to have an initializer. Initializer is another function that says what we must declare, right, in the beginning. So it's going to want us to have initializers, and for now let's just leave it as struct, right, and keep it simple. So the point is, we have so many objects in real life, but we want a blueprint that represents that in our program in a small way, not too complex. And that's what we call types. That's what we call a type. So this is an example of a type. Okay. And these are the most common type, the simpler types. But we can have so many types. Like, you can create anything. That's what makes programming powerful. Okay. So let's look at type safety. So type safety is a case where you can have a player name that is Julian, right? And you can have a score of 1000. Now what happens when you try to assign player name to player score, right? So it will tell you cannot assign a string type to an int type, because we know this is a string and we know this is a number. So we cannot, remember the equal sign is not, this is not an equal sign, this is an assignment operator. We're trying to take words on the right hand side and store it to the left hand side somewhere in memory. This represents somewhere in memory, right? This word here represents somewhere in memory. So if this somewhere in memory is a string, it's stored the string type. It cannot put a number inside the string, cannot mix it together, right? So that's why you get this error that says cannot assign. So this is why Swift is safe, because it can know the type that you are creating in a variable or a constant. And once you try and mix the wrong types together, like how we are assigning and changing it, it's not going to allow you to do that. So this is why Swift is safe. Okay. And Swift knows which one is string, right? Like this, without you telling it. It knows this is a string. It knows this is a number or a double. Okay. Okay, let's see if we can run this again. Okay, it must have crashed. It must have crashed. Okay. Let's just leave it like this for now. All right. Okay. So we can create a variable and explicitly say what type it is, like this. All right. We can say let city be a string, and the string is New York, like this. Right? Whenever we do this, we are explicitly stating what type it is. Right? We are explicitly saying that this is going to be a string. Right? So this is what we call type annotation. Now, if we remove this type, there are some cases where you need to explicitly state what type it is, because another thing is how Swift does is once you create a constant like this, it is going to do some kind of optimization, because it knows that that's not going to change. It's not going to go get it again, right? So because of that, it makes it faster to access, right? So the more you do it this way, it's going to be even more faster. So by explicitly stating the type like this, it's going to be more faster. So this is how we can do type annotation in Swift, like this, right? By using this colon and then putting the type close to it that way. And then we can assign it whatever type we want. Okay. So there are three common cases of doing type annotation. The first one is in this case, like this. When you create something like this and you don't assign it. All right. So this is type annotation. We are not accessing or calling it, so nothing is going to happen. But once we try to print it, let's say we want to print city, right? It will say, to throw an error and say constant city used before initialized, meaning the city is not going to be used. It is going to be used after the city is initialized. So this is type annotation. We are not accessing or calling it, so nothing is going to happen. But once we try to print it, let's say we want to print city, right? It will say, to throw an error and say constant city used before initialized, meaning we just have a constant called city, and the constant is a string, but we did not assign anything to it. So if you wanted to get what we assigned by printing it or calling it or using it somewhere else, right, it's not going to work. So we need to assign something like that, right? Now when we print it, it's gonna go get what we assigned, right? So the three common cases of using type annotation: the first one is when we create a constant or a variable before assigning it, like this, right? And then we assign it later on. The other case is when we create the constant or variable that could be inferred at two or more different types, right? For instance, this middle name could be one letter or a word, right? So a character is another type. So what's the difference between a character and a string? Will that work? No. Why? A character is not a string. This is a character. I don't want to put elf on that. This is a character. A character is a single letter, right? A single letter. But when we have more than one letter, like this, or let's say, let me use Lagos, like that, it's no longer a character, it's a string, right? So we have to explicitly state that this is a string, right? So that we don't confuse it, because they are all inside the quotation mark. So this Lagos is a string, but this once it's more than one character, it's a string. Once it's just one, it's a character. So this can be a string like this, right? And this can also be a character. That's because we're using double quotation marks. So anything we put inside double quotation marks is a string. But if it is one character, if it is one letter or one thing inside our quotation marks, then it is a character. So we have to explicitly say it like this. This L is a character. Otherwise, if we don't say it this way, it is going to take it as a string. Okay, so that's one way we do type annotation. The first one, create something, you haven't assigned it, and then you assign it later on. The second way, you want to explicitly say what is a character or a string, a float, a number, integer. That way you want to say what it is, right? And then the third one is when we create a type and we declare the properties, like we did in this person, right? This person type. So we have a person type and we have so many properties inside it. Okay. Okay, so we also looked at how if you just create a type annotation like this and you try to call it, you're gonna get an error because you're saying I want to get what is inside that memory location, but in this case you haven't assigned anything to it. So you must assign something if you want to get it, right? If you don't have it, it's gonna throw an error. Okay, so we looked at that. Okay, sometimes when we are creating a variable or constant, we can represent zeros this way if there are so many zeros, so that it's going to be easy to read. So let's look at that. Let's look at So what's the rent in Lagos? Maybe the rent in Lagos is 100,000. Then we can say print okay, the rent in city is rent in Lagos, and that will give us what the rent in Lagos is 100,000. Okay, so we can use this snake case or underscore to represent large numbers, right? Okay, so I think we've covered a lot. I wasn't even going through the lesson notes, just using the slide. I think I'll do this more. I'll just use the slide. Okay, so I think we've come to the end. Okay, so let's go over the playgrounds. So I'm gonna open the 1 second here, lab, and this lab is a little bit long. It's a little bit long. So what we're going to do is you're going to go through this lab, one exercise after the other. It's not too difficult, I promise you, and go through the ones for the constant. Try and create a constant, the variables, the step count, constant or variable, types and type safety, tracking. Just go through it. It's not going to be too difficult, right? And try and follow the exercise. Okay, I'm trying to keep this video to like 1 hour and not go more than 1 hour. Okay, so what we're going to do, remember, if you have your progress sheet, open your progress sheet and give yourself a score. I think we did this one the last time. Okay, so my progress wiped away for some reason. But once you put up your progress sheet, make sure you take it for this and add the scores. And for this second lesson, we're going to take it for the lecture, and then once we do the quiz and the extra reading, we can complete that as well. All right, make sure you're tracking your progress, and this will help you in the long run. Okay, so let's go through the questions for today. All right. Okay. So which of the following values would best represent a constant? A player name, player level, player score, location. The level, will it always change? That's what you ask. The score, will it always change? That's what you ask, right? So all these three will change, but the name, right? Maybe you want to keep the name forever. Okay, so one thing I forgot to mention is constants and variable. So if you used variables a lot, you're gonna start asking the question, what's the point of using a constant and what's the point of using a variable, right? Because if it all does this, just store something, like when should you use which one? So the convention is, whenever you're creating let me pull this up. Whenever you're creating something in Swift, you always start with a constant. You always want to start creating it with a constant. Why? Because when you create a constant, you want to form the habit of making things safe, right? So that, let's say you don't want to change it, then it remains a constant. But let's say you want to change it and you try to change it and you get the error, cannot change a constant. Then you can go modify the keyword from let to a var. So that way it's safer. Because if you created it as a variable initially, but you intended it not to change over time, and then somewhere in the program you changed it. Let's say, for instance, rent in Lagos is, you wanted it to be $1 million. That's how much you're going to make. And you accidentally used variable. And then maybe in line 400 or line 700. And maybe somebody said, oh, rent in Lagos, let me make it $10. Right? What happens? Now, if something else is asking for 1 million and sees $10, it's going to be like, what happened, right? So in order to be safe, you want to keep it a constant first, and then if it changes or requires change, you can go change the keyword. So I forgot to mention that, so that's why I quickly stated that right now. Okay, so which of the following would be best represented with a variable? So your name, maybe you want to keep your name in the program, right? You might not want your name to be changed. Or let's say your birthday, if your birthday changes, then it's not your birthday, right? What about age? Yeah, right? Maybe your age could change, maybe over time. And address. Right? Maybe you're moving about in the program from one place to another. So let's see those two, right? Okay, so your age and home address could be represented with a variable. It depends on the program, so you have to really think about it. Which keyword is used to declare a constant? Yeah, we know that's like, right? Which keyword is used to declare a variable? Right? That's a var. Which of the following is not a reason for declaring most values as constant? Right? So which one is not a reason? I think it is best practice. That's a reason for doing it as constant. And the compiler can make special optimization. I said that makes it faster, right? Because it already knows where it's stored. And it is safer because developers can rely on a consistent value. Like I said in the rent in Lagos, right? Might want it to stay that way. Right? Most value never change. No, some values can change. Can be variables. Right? So that's that. Using type inference, which of the following variables would be assigned a double? This one is going to be a string. This one's going to be a string. This one's going to be an int, and this is going to be a double. Right? Will the following code snippet compile? So you have a number and you explicitly annotate double, right? So let's check that out. So let number be a double equal to 3. So number is 3. What happens if we print the number? .0. So it's automatically assigned this 0.0. So because this is 0.0, we just ignored it, right? So yes, the compiler will assign value 3.0 to the number, right? Because we just did that. Okay, so that's it for the quiz. And you can take the quiz once you do the homework and the extra reading and complete the labs, and you can score yourself. All right, so that's it for today's lesson, and right now we're gonna go to the next section, which is the homework. Make sure you do the homework. So for this lesson, we're gonna do create a list, or I said create a list of constants. So this is supposed to be off. Correct it quickly. So create a list of constant and variable from your daily activities. So while you're going out, while you're just think of constants and variables, right? What can be a constant? What can be a variable? Look around you. Think of the types. Like, how would you represent this wall clock, right? Or how would you represent the mirror? Or how would you represent the door, or room, or an oven, or a fridge, a kettle? How would you represent conversation? Let's say agreement, right? And whenever you're using any apps, think about how you represent each things that you're seeing. That's going to be good. And also use good naming convention. So practice this. This will help you create variables and constants, and assign different types, and create your own types, and play around with it, and use good naming convention, right? And then the same thing, just create a custom type from your daily activities, and add as many properties as you can, and try and instantiate them like we did, right? For a person right here, try and do something like this, but for a different type. Okay, so if you've done all that, congratulations. That's it for today, and I am going to leave you with the quote of the day. Okay, so let's go to the quote of the day. So the quote of the day is, hard work beats talent when talent doesn't work hard. Tim Notke, right? So hard work beats talent when talent doesn't work hard. So think about it I think about it by myself, right? If I have a talent and I don't use my talent, then I can count on my hard work, right? So you might say programming is not for you, or programming might not work. But if you put some time and practice in your craft, if you put some dedication, if you put consistency, if you work a little harder, then your hard work might be better than just knowing it by heart, right? And then your hard work will replace your talent, and then people would say you're very talented at this, right? But that's because you put in the work over time. So keep on pushing, keep on going, don't stop. If you have questions, feel free to reach out to me on my Twitter, and reach out to the iOS community on Twitter. Make sure you don't get stuck, right? If you have any problem, reach out. Keep learning, keep practicing, keep learning, keep practicing, keep studying, keep programming, and you will get there. Okay, thank you so much for watching the video. Thank you for the likes and the subscription. And if you like this video, don't forget to hit the subscribe button, share it with a friend, and I'll see you in the next one. Peace out.